Hello, welcome to another episode of Beam There, Done That. And I'm here with my co host, Francesco Cesarini.
Hi there, I'm Francesco, founder and technical director at Talent Solutions, and yeah, as of last week, co-host of the Beam There Done That podcast.
And we have our guest, Paulo Valente.
Hey, nice to meet you all.
Hey, Paulo, tell us a bit about yourself.
Okay, so I'm here as a maintainer of NX, but I also maintain the gRPC library, the Elixir gRPC library, with my friend Adriano, and I'm a platform engineer at TV Labs, and I've worked with Elixir for the past 8 years now.
Today, I think what we'll be discussing is the whole NX ecosystem. Is that right?
Yes, what I want to talk about is the current state of the ecosystem as a unit in a sense, and also things that are growing in the different directions in which things are growing.
Okay, great. Yeah. So I have to admit, when Jose first told me that he wanted to bring machine learning and eventually AI, to the ecosystem, my initial reaction was, "You're crazy." That's basically what I told him. I was secretly excited by the idea. Well, not even secretly, I was excited by the idea, but I also understood the amount of work that would involve, and not just from a tooling and library perspective, as he would basically be competing with ecosystems which had many years head start. But the biggest challenge you would also have would be from an adoption perspective. And you might have the best tools, but you also need people using them. So I think today, I think we'll cover some of that as well as we go along. So go ahead and tell us, what is the current state of the ecosystem?
I have a slideshow I can share. The NX ecosystem has a few layers to it, and we have NX as the base layer, and then we have a few things that live beneath NX and a few things that live above NX. NX being standing for Numerical Elixir, and we call NX both the ecosystem and the core library that provides the foundations for numerical computing, and also a few facilities to building and operating on these computations. So when you think about numerical definitions, the defn macro, that's what NX provides. And NX also defines a behavior that we call the NX backend, which can be implemented by different native libraries, and also the NX compiler, which is a different interface, which can also be implemented by these libraries. So we have EXLA, TorchX, EMLX, and even NXERI and NXEigen that are also in the screen. They are what we call the backends, or some of the backends, which are implemented with native code. And then, for instance, EMLX can leverage the Mac GPUs, EXLA and TorchX can leverage CUDA GPUs, and NXEigen is CPU only, but it's very lightweight, so it's very easy to package an NXEigen into, for instance, your embedded device with nerves, and run NX with a greater speed than what you would get with plain NX without any accelerated backend. So this is what lives beneath NX, and then above NX we have a few things. One of those verticals is Axon, which provides abstractions for neural networks, which are the most prominent machine learning algorithms right now, and Bumblebee, which builds on top of Axon and lets us load models from Hugging Face, which is kind of like the GitHub of machine learning models. And then in a separate vertical, we have eVision, which it's not necessarily a backend, but it's a bindings for OpenCV. And it also can talk to NX using the NX tensor abstraction. And we also have Scholar, for classical machine learning stuff. So k-means, KNN, those types of algorithms, and Vega Lite and Toucan are data visualization libraries if you want to plot anything. So this is the general overview of the NX ecosystem right now.
NX, there's some kind of like sub language of Elixir that NX runs on, right? Which you didn't really talk about, which I thought was kind of interesting because I guess some
Yes.
functions they don't translate properly, I suppose, because you can run these functions like on CPU or GPU, and it also has different kinds of GPU or something. I maybe you can kind of make it more clear for me.
When we use NX, we'll generally use it in a similar fashion to this example module, which is you have your module, you import NX-DefN, and then you define your computation with defn or def transform. And the idea being that the final output of this function is going to be a data structure in the first call. It's kind of like a two-step approach where you define your code, and then when you call it, your defn function, you're gonna first compile that do end block into a data structure that's called an NX-defn expression, and then that NX-defn expression can then be either compiled with your NX compilers or traversed at runtime and executed through backends. And for that to work, that do end block inside the defn doesn't support the whole Elixir kernel. It only supports, it overrides the Elixir kernel such that the plus operator becomes NX add, for instance. And finally, by having that subset, we can provide that behavior that I mentioned, the NX backend behavior, and then that data structure can be compiled. And when I say compiled, it actually produce bytecode to be run into onto your CPU or your GPU, your CUDA GPU, your ROCm GPU now. And Xerie can also target WebAssembly. So I already gave presentations. I think Francesco was there actually with running NX on the browser through an Xerie. So that's the power you get from having that subset of Elixir instead of having to support all of Elixir.
Can I ask, when is it recommended to use NX? And are you actually using it yourself in production?
The way I think about this is, does Elixir solve my problem, first and foremost? And if the answer is yes, then I will use Elixir. And when in solving that problem, I find the need to use AI stuff, machine learning stuff, then NX is the entry point that I use for that. I wouldn't, if your problem is, hey, I need to solve this machine learning problem, you probably don't want to start with NX itself. You probably want to train your models in Python and so on. But then when you want to get those models and deploy them into your production environment, then you can maybe write a Bumblebee model or an Axon model to load them if they are neural networks, or you can port your code over from NumPy, PyTorch into plain NX, and then use that to load your code properly and run it natively on the Beam. And yes, I am using it in production. I work at TV Labs. At TV Labs, we do real-time data processing, video processing more specifically. Those video streams, they need to be processed for image inference and so on. But also we need to run pre-stream calibrations, and those pre-stream calibrations are calculated in NX. We also have some data analysis tools that we use internally that use They currently use Python, but they are in the process of being ported over to NX because I needed a few features that weren't released yet, but they are now released in NX 0.11, which is the latest release.
One of the things which you just said right now, which kind of is what got me originally excited in machine learning and AI on the Beam and the whole NX ecosystem when I first heard about it, is the ability to run everything in the same memory space. So if you go back almost 20 years now, well, it is 20. If you go back 20 years now, we had what we call the Lime stack, Linux, yours, Erlang, Amnesia, where we had Erlang-based web servers, which would receive the HTTP requests. We had business logic written in Erlang, which would retrieve, the request, it would parse them, and they would then look up data in Amnesia, which was again, the Erlang database, which was running in the Beam, and we would be able to, generate dynamic web pages in, at the time, so 20 years ago, in milliseconds. And it was all because there was no I/O, there was no encoding and decoding, there was no reads from external databases. And the less components you have, the less the risk for error or something going wrong. And not only that, an incredible increase in speed because things went incredibly fast, and also a huge reduction in energy consumption because you were using much less, you were serving many more requests with much less hardware. Is the same possible with the NX ecosystem today?
It is possible, and there are a few different approaches to that. So we have PythonX, and PythonX does support passing binaries by reference, if that makes sense. And we, besides all passing binaries as references, we can also pass just plain objects, Python objects, back and forth. We can carry those references around. And if you have the proper glue code, you can get, let's say, a pointer to the memory to which your tensor points, pass that into Python, and load that as a NumPy array, for instance. And with that, you really have to be careful because you're passing data ownership. Things can get messy very fast, given that NX tensors are supposed to be immutable. But you get the power of doing zero copy transfers between NX and Python. And the same works in the other direction. You can get a pointer to your NumPy memory, pass that back to Elixir, and load that as an NX tensor. We have what I can call the old way to do it, which is using an X2 pointer and an X from pointer. But there are a few new ways that are coming with, and you just using an X from binary and to binary, and in the future from Python and to Python, to properly do that without having to manipulate pointers. And I'm using CPU tensors as the example, but the same concept apply to GPU tensors. So you could have your tensor living on the GPU, you pass the pointers around, and then magically your Python code that lives in the same process space because it's running in a Python instance owned by PythonX. So you're not transferring between OS memory spaces, host OS memory spaces, but then you're transferring the ownership of a pointer to the GPU memory. And with great power comes great responsibility. You can get pretty messy with that, but it's also very powerful.
It's reminds me again. I don't think the whole ecosystem was that advanced at the time, but Chris Granger gave a really, really good keynote about a year in production with machine learning on the Beam at CodeBeam Europe in Berlin in 2023. I'll just share a screen of I'll just share a screen of it. What he was saying was that with that, by doing that, he was able to, as a startup, they were saving six figures on their AWS bill. A lot of the savings came from not needing any intermittent storage, by needing, as a result of needing just less hardware to run everything. Yeah, it made it so much easier, but so much more cost effective as well, to do it. So yeah, I'd recommend everyone to go actually in and look up this keynote and listen to it, because I think it will resonate with a lot of what Paulo is saying right now. I have one question, and then I'll pass over to Alan. I'm doing all the talking here. When should you not use NX?
I guess this is basically the same answer to when you should use it. And I have my personal experience with that. When I worked at Dockyard, we were exploring using reinforcement learning for sailboat path tracing. So basically, for a sailboat to find the best path for a sailboat to go from point A to point B, given wind direction and so on. I ended up writing a whole library called Rain, which currently lives on the Dockyard GitHub if anyone wants to take a look. It's a reinforcement learning library built on top of NX. I don't maybe yeah, action models are the thing there. I don't do action loops, but the library is built on top of NX. I ported over a few reinforcement learning algorithms, and in retrospect, I should have just used Python to explore those ideas. The point what I mean, part of the point was to prove that NX could do that as well, but it would have been a lot more efficient, resource efficient, cost efficient, to just run the training in Python, in the native things that where these algorithms were born. And then after we had the algorithms defined, or at least chosen, because there are a lot of reinforcement or learning algorithms to choose from, then you could take the model, you would rewrite the same code, the same neural network in Axon or plain NX if need be, and then just deploy that into your Elixir project. So yeah, I guess the takeaway is, if you're doing exploratory stuff in the machine learning ecospace, not in the machine learning deployment space, then you should go directly to where those things actually live, which is Python. And X is a great way to deploy things. You can train, you can fine tune, but you probably don't want to start from scratch.
Okay, thanks for that. Yeah, I think we've all drunk the Kool-Aid. I think learning to use the right tool for the job rather than the tool at hand is something, which comes with experience.
Yeah, I'm kind of curious about the whole NX ecosystem. Is it possible that we could have it so that it's a little bit more like Beam friendly? So say like Erlang could have their own flavor and Gleam and so forth, or is it just NX can only ever be Elixir for some kind of reason?
Most of NX can be used from other Beam libraries. The only features which can't be used from outside of Elixir right now are a few features that live in the NX kernel module. And if I recall correctly, the only ones that live only there are cond and while. Cond being the translation of the Elixir cond, but for NX, so just nested if else's. And while being the way to do native loops. So you have a condition block, an initialization block, and the updating block, much like a C while construction, or maybe a for construction. Those can only be accessed right now from the Elixir kernel, sorry, NX kernel, which relies heavily on macros, and then that's not accessible from other Beam languages. That being said, These past few days, I'd say, ever since we started talking about this podcast, I started thinking about how maybe those features could be accessible from outside of the defn kernel. And I don't think there is an easy way, but there might be a way for us to expose those features. Jose is probably hearing this for the first time right now if he's hearing this podcast. But this is definitely something that I want to explore, if not for NX 1.0, definitely for 1.1. And NX 1.0 is close.
Yeah, I remember hearing about NX a long time ago, and I went to take a look, and I'm like, oh, it's 0.11. Like, it's such a small number in retrospect, but then again, like, every number is basically, what do you call it, like arbitrary to a certain extent, right? As long as the number's going up rather than going backwards, right, then at least you're making progress.
Yeah,
so
definitely.
Interesting to hear it's finally going to be 1.0 at pretty soon. Because I think that 1.0 will...
Very...
Sorry. I was just going to say, like, I think that 1.0 kind of gives people, like, satisfaction. Like, okay, this is stable, right? Even though it's been stable for probably for some time, right?
Very early on, we agreed on a few features that would be very important for us to have for 1.0. And in the development of those features, as well as base features that we already had but didn't quite work, we started figuring out the kinks and learning that, hey, our abstraction for grad is kind of mixing up two different ways of approaching that. And when things develop, interfaces break. So it's nice for you to not have to bump your major version every time you run into those. But NX right now is in a place where we now have runtime call, which lets you interleave non-NX code into your NX computations. It does a bit of NIF magic for getting that to work. But we have that, and then we're developing currently with an open pull request even for that to work with CUDA. And then we need that plus a few other features that need some polishing before we can call it 1.0. But the goal, and I think it's a very achievable goal, is that NX 1.0 is coming this year, still 2026.
Actually, I did have one more kind of question. Because of this podcast, right? I wanted to start to actually add more AI and help me out to kind of edit things. I was using Open Whisper I think it's called Open Whisper or Whisper, to kind of suck all the subtitle data out, and I wanted to analyze that and see about pulling out some clips. I had the most frustrating time, which I'm hoping that we're not going to have this with NX Elixir, which is like, I think the latest version of Python I think was already on my machine was like 3.13, but it turns out that Whisper needs like 3.9. Like, for some weird reason, Python is just so frustrating when it comes to versions, and the more like stuff you're in the AI, I'm guessing the more you're gonna have. I mean, for people who are just listening, like Francesco is just like enjoying my frustrations with Python and trying to get into the the analyzing of the data. It's so frustrating. I mean, I was a Python 2 developer for a long time, and then when 3 came around, that was hell. I still feel we're still in the hell. I'm not sure about what you guys feel, but yeah, sorry, go ahead.
I'm smiling and laughing here because everyone goes in and tells Ericsson, "Oh, you're so conservative with the release of the Beam and the release of Erlang, and you don't do any, all your changes need to be backward compatible. You never break anything." You, as an individual user, will frustrate. Imagine having tens of thousands of radio base stations and the inability to not be able to upgrade to the latest version of the Beam, and get all of the speed increases, enhanced concurrency, the JIT compiler, or whatever that upgrade might bring to you, because they've changed an API of one of the key libraries, and it's one of the reasons why Erlang has evolved so slowly. Just avoiding breaking all of these things and ensuring that everything you do remains backwards compatible. These stories are exactly the reason for it.
I'm okay with things breaking, but give me something for it. Like if you give me a 25% speed increasement, okay, fine. But the problem is that I just pulled the data in 3.16 or whatever it was I was running. It's not that long ago. I don't know what 3.9 is, probably quite some time ago. Like, but I don't think there's generally a huge difference. But yeah, anyways, it's more of a frustration. But I'm guessing that you don't have this kind of problem with the different versions of Elixir. I know I ran into this with like OTP 28 that just came out. Like so many libraries were busted, but that seems to be fixed. Hopefully 29 will be smooth. I haven't tried it out yet. Yeah, so can you tell us about like, how you guys are handling versioning? Is it a problem?
Well, what I can definitely say is that I only recall one hard breaking change that we introduced to NX ever since I joined, which was very, very early on, in which we used to have transform as a function inside FN kernel for like using regular Elixir to define your defn expressions. I particularly found that very confusing because if you defined your anonymous function that you would be passing to the transform function inside defn, you would have to call everything from Elixir kernel by the full name, not the usual names that we use, which is auto imported. And if you defined it as a defp, you would then be able to do it normally and then pass that as a function capture. That was very confusing, and we changed the feature. I think it was in 0.4, 0.5 maybe, to def transform, which does the same thing, but it always forces that, hey, define this in a separate function. And that was a breaking change. But aside from that, 0.x is more of a safety net for, hey, maybe we'll find some breaking stuff on features that we're developing or in an experimental stage, and we won't have to bump from 1.0 to 2.0 just because we need to fix that interface specifically. Or hey, we need to introduce this backwards compatible change because the previous interface was incomplete, but the new interface is incompatible with the previous one. So it could get kind of messy. So 0.x is kind of the safety net for that. But definitely the philosophy that comes from Jose, and I always try to embrace, which is to embrace change without breaking things for current users. Try to introduce retrocompatible fixes or changes if need be, but don't really break, or if you need to break, at least have one release where the previous feature, the previous version, is soft deprecated before it's actually removed.
I think we got to clip that out and put that into a short and share that. It's a really good quote.
One of the things, when Jose, created Elixir, I think one of the key points is, to get users, to attract users with a, sense of familiarity. Do whatever he could to reduce the barrier to entry. Do you feel, the same is being done with the whole NX ecosystem?
We definitely borrow heavily from JAX, which is the Python library for functional style machine learning programming. A lot of our features and interfaces are borrowed from JAX, but turned into the Elixir philosophy way of doing things. We try to use common names, although we generally tend to err on the side of using the full names of things. So, for instance, in NumPy, PyTorch, everywhere that you run into the cumulative sum function, it's going to be called cumsum. Cumulative product is going to be called cumprod. We call that cumulative sum, cumulative product. I think that's the main way from where in which we break users' expectations. But personally, I feel like that's not a really bad way to do it because we're being more verbose and having increased clarity if you're not already in the machine learning space. I'm not sure if that answers your question necessarily, but that's how we try to stay familiar both for Elixir people and machine learning people.
This leads me, to my next question. What is the best way to get into the ecosystem and actually start using it? What would you recommend? Resources, approaches, tools, libraries?
So we have a few learning guides in the NX Hex Docs page, which we worked on in 2025. Those are good for learning NX itself, the kinks of the library. So if you already know a bit of NumPy, PyTorch, maybe that's where you want to start. And then Axon has a few guides as well for how to use Axon. Bumblebee, the same for Bumblebee. One thing that I really like to do when learning something new, and this is not just for machine learning, it's for anything, is I choose a high level application or some goal that I think is achievable beforehand. And then I try to get that to work. And in trying to get that to work, that's going to shine a light on things that I don't know, some implementation details or mechanisms that I don't know how they work. And then I can use that as a guiding thread for me to research, look more into how Bumblebee uses Axon and then how Axon uses NX. And maybe I'll bump into how automatic differentiation works with all of those libraries. That's one part of the process. And I think the other would be, for instance, there are quite a few talks about NX out there, some by me, some by Chris Granger, I think a couple by Sean. So maybe those are good talks to if you want to learn more about the internals. There are a few applications of NX as well. Talks at ElixirConf. Those might also be good places for you to get to know the ecosystem as well as finding applications for you to try and reproduce. And also there's Sean's book by Prog, which is a great book for you to learn NX itself. And in a separate vertical, if you want to learn machine learning, there are quite a few resources. Too many for me to mention, but definitely courses by Andrew Ning are good courses for you to look out for.
Where will we see you speak next?
Well, hopefully at ElixirConf US 2026, I submitted to that.
So yeah,
Probably something online is
US.
going
Yeah.
to be. Excuse me, sorry.
So ElixirConf US. Yeah, that's September 10th and 11th at Voco in downtown Chicago. Yeah. And just a heads up, you want to speak alongside Paolo? The call for talks closes April 12th.
And hopefully also some online meetups are going to pop up between now and ElixirConf as well. So definitely you can follow me on Twitter whenever I get the opportunity to participate in online meetups and so on. I share it on my Twitter X page.
We also hope to get you back, have a podcast over what you're actually doing at TV Labs, because yeah, it's a really, really exciting startup, which I think we'll be hearing a lot about. Do some really, really cool and fun stuff, not only with Elixir, but also with Blue Earl, Nerves, and yeah, and a lot of really interesting components. So yeah, hopefully, we'll have to arrange that.
It would be great. Looking forward to that.
I think we're starting to approach kind of the end of our time. I'm afraid, like, we have a little bit of time. I wanted to ask a question, but I'm worried that we might go a little bit over. Maybe we should keep it for the
I can
next
answer
time.
really fast.
I mean, actually, the only question I had was I was kind of curious because you mentioned about sharing the memory space with Python, I believe, if I remember correctly. I was kind of curious about, you can also do that with like NIFs and things like that?
Yes. So if you want to play around with those without having too many examples, you can see a bit how to glue this code in my lightning talk from Elixir US 2025, where I showcase a prototype of an X runtime call. So that's one of the moving pieces. The other is the others that you might want to leverage are just an X2 pointer and from pointer, which can also do IPC handles, which is moving those pointers between host OS processes. So you can have quite a bit of fun with that. And nifs do play quite nicely with those features, given that you're operating on pointers. We don't have too many examples, so you have to dig around in the code because those are dangerous features that should not be documented yet.
It's like a post like 1.0 kind of thing, no?
Yeah, we probably will have a better, nicer, more user friendly way of doing that, even for 1.0. That's the goal.
Yeah, I mean, I don't have anything else on my side. Francesco, how about for you?
No, that's it for me. This was really, really informative. Big thank you. I've learned a lot today. It's great to see the ecosystem continue, but at the same time, we're also reusing, I think, a lot of the lessons learned, from the past, 25 years, from the Erlang ecosystem. And it's great seeing them being applied here. And maybe, after all, Jose's idea isn't that crazy. I think, you guys roll onto something. So yeah, good luck.
Yeah, thank you very much.
Yeah, and this episode was recorded on March 4th. No, it was great having you on. Yeah, thanks again for coming on, and yeah, looking forward to your talk coming up in Chicago.